Well, welcome everybody. This is the Cloudology podcast, episode 2. I would like to kind of upfront apologize that we had such a big gap between episode 1 and 2. We can blame that on our friend Carter Shanklin, who is in the middle of the annual planning, customer problems. We also had a hackathon that we were all participating in as well. So our dates did get a little pushed, but here we are, and I'm really excited to kind of talk about the topic that we have today. Which is all around high volume, high performance SQL in the cloud.
It was worth the wait.
It was. It will be worth the wait, right? Absolutely. So I'm Jeff Thomas, your host. I'm a big data architect on the Oracle A team. I also have my co-host with me here, Larry Fumagalli. He's the principal cloud architect for the Oracle sales consulting team as well. And our special guest, my good friend Carter Shanklin, product management of big data products for OCI, the new cloud infrastructure platform that Oracle Cloud leverages. And I'd like to give Carter a second here to introduce himself as well.
Hi, everyone. I'm Carter Shanklin, product management, and I've been at Oracle about 3 years, been in the big data space for a little over 10 years, I'd say. And so great to be here. Thanks, Jeff, for inviting me. I got 2 little ones that keep me pretty busy. You might hear them banging around in the background or screaming their heads off. So if that happens, hey, we're all living the dream right now. It's funny. We had an in-person offsite last week. It was wonderful. I got to get out of the house and I always joke and I always say, hey, going to the office is like a vacation for me. But some days it feels like it's not really a joke.
Yeah, that's awesome. Yeah. So did you guys do the offsite in San Fran or did you do it in the new Texas?
We did it in, we went to Monterey. Went to a little place in Monterey. It was nice. We had about 8 people come in. We had some good discussions. We plotted a new course. I think things are looking up, and it was it was good, very productive. So looking forward to getting life a little more back to normal.
Yeah, I know it's crazy. Every time I go to the grocery store now and I see people without their masks on, I'm like, what are you guys doing? We're not allowed to not wear masks. Before I realize, I'm not even wearing my mask, right? Because we're all vaccinated. So it's one of those things that's it's going to take us a little while to get used to, I feel like.
Oops, sorry.
Yeah, go ahead.
Hey, Carter, I got a question for you. Do you find, now that you've been back on site again, and you are responsible for getting these products rolled out and the roadmap and all that kind of stuff, do you find it a lot more effective and efficient being together to do that? Or were you able to, okay.
We sat in a room for 2 days. It was one of these, lock everybody in the room until we figure everything out. Never would have happened on Zoom. Never would have happened on the phone. Just it's so much more productive in person. I think
it's really interesting to see where things are, because there's certain things that are more productive and there's certain things that aren't, right? And I think it's going to be really good now that we can move together as an industry, really the whole IT industry, and pick and choose. Like even companies like Google, who have refused to let people work from home, are now starting to let you work from home as much as you want. And I think that's great. I think that there are days, like you said, where you want to work from home, but there's also going to be certain things where it's just way more productive to be sitting face to face and hold people accountable for their time, etc. So for sure.
Absolutely.
Awesome. All right, well, let's get to the topic at hand. What we're talking about here today is high volume SQL, right? So we're going to start with what is it, where did it come from, why does it exist, why is it a thing, etc. So we'll start with our favorite kind of old history lesson diagram that we're going to be pulling out pretty much on every call probably, which is our traditional architecture for the last 35 years of our enterprise data warehouse, right? Data sources going into staging, ETL processes, moving all this data, usually in batch, boom, 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 on a nightly basis, building out our data warehouse tables so that our end users can consume it, data scientists, analytics, reporting, etc. Right? That's where we were. Over time, this infrastructure became extremely expensive for large volumes of data. And the other big problem is it couldn't really handle unstructured data very well. So JSON files, even things like CSV, raw CSV coming in, you couldn't query over them without doing lots of transformation, which is complex, costly, etc. Right? So for a couple of those reasons, plus many more, we started to all turn towards the magic bullet that was going to save everybody, which was Hadoop running HDFS and MapReduce, right? So now we could write custom Java code, run those jobs to do these transformations, have super high scale, cheap, right? Running on commoditized hardware, super cheap storage, super high scale ability to, kind of change this data, manipulate it, whatever, so that we could use it. So it became extremely convenient. We started seeing all these 10,000 line Java MapReduce jobs floating around out there. And the skill set was very niche, right? You had to have a very specific type of Java developers that could handle writing this. And so what was the first thing that everybody asked for once we hit, the enterprises started hitting the ground running with Hadoop, right? The very first thing, SQL access. Can I get some SQL access? So one of the great things about Carter is that he actually was the project lead for the Hive project. For how long, Carter? A couple years?
Oh, longer than I care to remember. I don't know, 4 years, 5 years.
4 or 5 years. So I'll let Carter maybe talk a little bit here to, what do we mean by high volume SQL? How did it come about, and what is Hive?
Well, yeah, I mean, if you look at the history, MapReduce came out of Google, and MapReduce was really designed to index the web. This is how they built their search engine. And you can't index the web with a database. The types of data, the volume of data. You need something different. You need something that's more scalable. You need something that because if you look at SQL systems, were really built around. They're very tuned for financial applications, closing the books. You don't need any of that stuff when you're crawling the web. So as the web started to take off, as mobile started to take off, you saw these new types of data, unstructured data, log data. They're not, the value of an individual log file line, not very great, but you got massive amounts of this stuff. So you just need a fundamentally different architecture. That's where MapReduce comes from. That's where things like HDFS and scale out systems come from. But yeah, I mean, as it started to penetrate the enterprise, people say, hey, I'm not indexing the web over here. I'm just trying to, look through my log files and figure out how many customers visited the website yesterday. How do I do that in a meaningful way? So people wanted to be able to take their familiar technologies, SQL technologies, they wanted to take their SQL tools and say, I love the scalability, I love the cost that this architecture brings, but I just can't get value out of this without SQL. And that's where projects like Hive, and we used to call it basically the SQL on Hadoop wars. If you think back to like 2014, 2015, a new one of these SQL on Hadoop technologies was coming out of the woodwork every couple of months because everybody wanted to get to taking advantage of their familiar tools or familiar technologies. That's where technologies like Hive came from. And I think we're also going to talk about a couple of the other technologies that came out of that. But fundamentally, for the business, you need SQL to drive value out of any data set, and you need that SQL technology to be able to access that data set.
Absolutely. It also makes the most important and widely used use case for all of Hadoop, which is word count. It makes that a lot easier to program, right? Just select star count, done. You don't even have to write a line of code. So that's actually just want to make that clear, Yeah, and so as you mentioned, there's a lot of other things that went on, right? So we have things like NoSQL that were beginning to play a role, like your columnar stuff, your HBases of the world, your Couchbases, your
Mongos.
What am I looking? What's the one that starts with an
MongoDB?
MongoDB. That's what I was looking for, right? You can't even do a join coming out of the box with Mongo, right? And they started to enrich their SQL capabilities. And then, of course, we also have things like Apache Phoenix, which is an ANSI layer that would sit on top, an ANSI SQL compliant technology layer that would sit on top of HBase, for example, right? For this same exact set of use cases. You had Hadoop vendors like Cloudera coming up with their own kind of high-speed, high-performance SQL layers directly to solve this performance issue of high-volume SQL. And then you had a lot of other cool technologies. I think Presto is one of these that's a little bit more unique. It has its own kind of architecture and stuff. but again, has a lot of adoption there and handles loads that a lot of other technologies can't handle, for example, and still running in production today. And then, of course, we can't forget Oracle. Oracle focusing on the enterprise. We built something called Oracle Big Data SQL. It was really focused, and it still is really focused around a big data appliance with Exadata, right? That was kind of the bread and butter play there. Those large engineered systems where you could actually leverage the smart scan capabilities and the internal workings and algorithms and even hardware of the Exadata platform at scale on the Hadoop cluster, right? So it was a really nice match of those two things.
And just to add, though, you can find remnants of this in the autonomous data warehouse, right? They call it,
yep.
I think it's called ADB Data Lake Accelerator, I believe what it's called.
And we also still have
beginnings there, yeah.
And we also still have the Oracle Cloud SQL service, which is going to be coming out to GA very soon. That's still leveraging the same set of capabilities, right? It's leveraging the same agents that we're running out on the Hadoop nodes. It's still leveraging that same underlying set of technologies to do scale out SQL, right? Yep. And kind of wrap it up, this is what I thought of first when I kind of looked at this problem. If you're not a football fan, you won't get this reference, but this is an old Bears, I think it was a playoff game where the Bears played Arizona and they lost in this really ridiculous way. And Denny Green was very famous for kind of having a meltdown up there, but he said, they are who we thought they were, right? And that's really what I thought about here is when we all did nothing but SQL for 25 years. So the fact that we thought we were going to move ahead into something like HDFS, MapReduce, something like that, where everyone's going to just start coding everything in Java without, falling back towards these SQL requirements. It's very cyclical, right? Every time something new comes out, we always run away from SQL. We're done with SQL. We're moving on to this cool Spark API that runs Python, or we're moving on to this cool MapReduce thing that runs in Java. What we always find, though, is that we always come back, and it turns out that our end users, our customers, they are who we thought that they were from the beginning, which is somebody who wants to consume their data in SQL, right? I don't think that's ever going to go away.
And all their end user tools, right? I mean,
absolutely.
All of the reporting services and all those, what are they most proficient in? Yeah, SQL. Right?
Exactly. They're built from the ground up to use that. It just makes a lot of sense.
Yeah.
So
I used to joke, Jeff, I said, the journey of big data basically goes, everybody starts with NoSQL, and then they realize, hey, I can't use this thing. So the journey was like, you start at NoSQL, step 2 is slow SQL, and then step 3 is SQL. And the journey from NoSQL to slow SQL, we certainly lived it. I certainly lived that. But I'd say, after 8 or 10 years of continuous investment, what you can do with these tools these days is pretty impressive, and the scale and the speed is really quite impressive. You can do a lot with the current crop of technologies that are out there.
Absolutely. And I think even database, I always joke around with Larry that as a big data architect, I spend more of my time trying to convince a customer not to use big data than I do trying to have them fit into a big data technology, just because so many people have no business using big data capabilities, right? Because the database could solve their needs, and it has better security, better user and authorization role management, blah, 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 way easier to maintain, way easier to manage, whatever. So I think, we'll talk a little bit more about that in a couple of slides here around when does it make sense to use these technologies as well, because I think that gets lost a lot on us as we're getting excited about how great these technologies can be and what they can do.
Yeah.
And then where are we going? It's really simple, right? So originally, what it looked like, whether you're using Hadoop or not, right? The general use case was always the same, or the general high-level diagram is always the same. Of my data sources, I have a big staging area. I have some big processing tier where I'm building out a warehouse. I'm doing data integration, ETL, whatever, to kind of make my data presentable and add structure to the unstructured data, et cetera. And I need to do all that so that I can then provide that data to my end users, right? Whether it be for reporting, data science, whatever. Where are we going? We're going to a cloud native approach where I can just have technologies that can sit on top of my source data that's sitting in my object storage, that's sitting in my Amazon S3, that's sitting in my Microsoft Azure object store, and then allow me to have that high-speed SQL access without having to do all the work in between, right? That's really where we're going. And we see Google BigQuery out there. We see Amazon products that They're working towards this with things like Athena, which are scale out large
Spectrum.
scale SQL languages. And we see it with, obviously with Microsoft Databricks, they're working towards that same type of thing.
Yeah.
And of course at Oracle, right? At Oracle, we also are working towards that same type of capability with our Dataflow Interactive.
Yeah, you bet. Yeah, I mean, just to jump in a little bit, I think that we, the traditional big data architecture, a lot of it was, okay, I'm going to have my flat files, but I can't do reporting directly on that. What I need to do is I need to do this kind of big, expensive or complicated preparation phase and then load that into the warehouse and do my reporting from there. So that's a very, very common, very traditional big data architecture. Very complicated, and people are just generally unhappy with it. So in the industry, there's this meme going around of what a lot of people are calling the lake house. So a lot of people are throwing that term around. And a lot of that is really the desire to get rid of all of this complexity. We want to ditch that complexity so we can move faster, we can go further, but somehow to be able to treat the lake more like it is the warehouse. So you don't have to have this intermediate step. You don't have to have 2 copies of the data that you can never keep in sync. So there's this big trend, a big meme in the industry is this lake house. How do I use the lake like it is more of the system of record? And so that's where you look at things like big data SQL, if you look at things like Cloud SQL, if you look at what we're going to talk about, Dataflow Interactive, it's all about reducing that complexity, using the lake more like the system of record. And ultimately, the lake is your data fabric. The data is there. You can attach your engine of choice, do the analytics on the data in place.
Absolutely.
And that came up, I think, from going back to your other slides, right? When HDFS, when Amazon basically said, hey, S3, you can just throw a lot of data out there. You don't need to bring the compute along with it, right? And you had those 2 divested, right? You compute,
Right.
And then you're able to, like you
Separate.
mentioned, have those different compute engines, whatever you wanted to compute best on, and however you wanted to process that data best,
Absolutely.
right? You get to pick,
because different tools are going to have the different sweet spots. You look at warehouse, it's great for high concurrency, low latency. If you look at some of these open source tools, they've built up solving the problems of extreme scale. So different tools are going to be good for different uses. And we don't want people, though, at the same time, we don't want people to have lots of different copies of the data running around, because that's very hard. You're never going to keep that in sync. Different systems are going to give you different answers for the same query. Everybody hates it.
Right.
You can't govern it. Yeah, exactly. Yeah.
But I do still think that for certain industries and certain vertical use cases that you're always going to still have your traditional warehouse, which you kind of just
Absolutely.
Yeah. Right. So I
nobody's
think
going to, nobody's going to close their financial books on a lake house.
Hadoop. Yeah, absolutely.
Nobody's going to do that.
Exactly.
So,
but like you're saying, though, you changed the paradigm, though, right? All the data would go in a staging way into your lake, I would call it, right? And you could be a thing by lake house, but as part of that, the warehouse would be in and go through its cleansing curation process, I'll call it, until it gets to the warehouse. So
the warehouse just
follows the
becomes
same
a
paradigm,
consumer. It just becomes a downstream consumer of your lake house, and it just makes the line to the other consumers much more clean, right? Because there's no reason why my data scientist should have to consume from my warehouse. And in fact, here's a great example, right? When a data scientist is consuming from the warehouse, what is going to happen 100% of the time for him, right? He's going to have to go get access to some other data out there, right? The warehouse is not going to answer his questions, because the warehouse is built to answer a very specific set of questions that he's not looking for per se. Some of the data he needs will be there, but not all of it. So now he's back to ETL jobs, writing a bunch of scripts, doing something to put the data together into a view that allows him to do his work. And that's where having this, like you said, Carter, this kind of intelligent data fabric that can give you your answers much more quickly at scale with a lot more of intelligence built into it, makes their job way easier, right? For sure.
Yeah.
Absolutely. That's really good. So I want to probably just spend just a quick moment on this, Larry. So we don't want to.
No. Just to go, just to show you.
Where does this fit in our modern data lake architecture that we've been talking about?
The cool part is kind of what Carter just said. This is what we've had for a while, so we're on the same page. So that's always a good thing. That that this is it, right? This just shows you exactly what he was saying before. We didn't put all the processing engines in. Oh, they are here, right? So the data lake is here, and I'm going to call it. We've always used the data lake in our conversations as that lake house, right? It's not just a place to store your data. It's the processing engines around the data, governance around the data. And that's kind of what this picture shows, right? This would be, like Carter was talking to me, that is your lake house right there, right? Is your data lake combined with the enterprise data warehouse, your departmental data warehouses, but all your data comes in here first into the data lake. So, and it's surrounded by the different processing engines, whether it's data science, analytics, your data engineering, all surrounds that central repository, right? So that is this picture. And the good thing is, well, we're all, like I said, we're all in sync. So there you go.
Yeah, and under the covers in this picture is a lot of work, right? There's
Yes.
a lot of ETL processes, and there's a lot of jobs, and there's a lot of configuration, there's a lot of headache. And these technologies that we were just talking about that can provide that SQL layer, that dynamic SQL layer on top of your unstructured object storage data, that's where you start to gain a lot of benefit.
Yeah.
Yep. Speed to data, right? The speed, your opportunity to get it faster.
All right, so we'll kind of wrap this thing up with, that's all really good, but you know, at the end of the day, we all work for Oracle. What is Oracle doing, right? What are we doing as an organization with our big data platform to kind of address this problem, and kind of what differentiates our kind of approach to this from the market, right? I mean, that's really what we're looking for here is, you know, not just what we're doing, but why is it special? And I really do believe that what we're doing has some really unique benefits for sure.
Yeah, like the first call. I mean, the first question we get from most of our customers is that, why Oracle? Why should we go with Oracle? Is exactly the question we get.
On some of these topics, it's even just what do you mean you do this, Oracle, right? I'm still so surprised that we're still hearing customers that don't even know that we do these types of things, right? They kind of draw the line at database. So it's definitely good to get this information out there. So Carter, if you want to take a stab here and kind of do some initial conversation, that'd be good.
Yeah. So I run the Dataflow service. Oracle does have a suite of big data services. Dataflow is one of them. We have a Hadoop service called Big Data Service. I'll just mention briefly before I move on. But if people have on-prem Hadoop workloads, they want to move those to the cloud, we got a way to do that. They can just basically lift and shift. And then they can decide if they want to modernize or not, which we certainly encourage. Yeah, I was in the Hadoop space for a long time, and the hardest thing about Hadoop was the complexity that people were dealing with. And part of this was because you really had to be an expert from the stack top to bottom. And a lot of Hadoop didn't really auto-tune. It didn't really kind of auto-scale or auto-tune. So people spent a lot of time getting the system to work and perform at an appropriate way. So what we wanted to do is we wanted to kind of try to simplify people's lives. We wanted to throw out most of the complexity of the Hadoop ecosystem. So what we said is basically, hey, in the Hadoop ecosystem, there's this tool called Spark. If you've been anywhere close to big data in the past 5 years, you certainly heard about it. But really kind of Spark started to take over the Hadoop ecosystem. So what we said, hey, we're going to pluck Spark out of the Hadoop ecosystem. We're going to make a very simple consumption layer and really just simplify access to the Spark ecosystem. And that's what became the Dataflow service. So Dataflow, the charter and the goal of Dataflow is to make it easier for you to deliver those big data applications, because you're just writing your code, and we're taking care of all of the grunt work that you fundamentally don't want to do. Okay, so it's fully managed service. You don't deal with VMs, you don't deal with software, you just deal with your Spark application code, and we take care of the rest. So we started this, we launched our Spark service back in February of last year. And that's been that's really I mean, the people who've used it basically say, hey, fundamentally, this is easier than EMR. This is easier than the other alternatives that are out there. So a lot of good praise about that. Very soon, we're also just like the observation we had before is like, okay, this big data stuff is cool, but where's my SQL? So pretty soon, this will be coming out later in this calendar year. And we're actually going to be going into limited availability in about a month or so. But we're introducing an interactive SQL extension that's going to allow you to provision big data clusters with a SQL endpoint, very easy to connect your BI tools up to. Then you can connect to that cluster. You can start discovering the data that's in your object store. You can start analyzing. You can start refining it. So we call this Dataflow Interactive SQL. And the idea behind it is really just to simplify discovery and analytics of these structured and unstructured data within your object store system. So if you have the luxury of seeing this the video here instead of just the audio, effectively this cluster, it's a SQL cluster. You connect to it via your ODBC or JDBC client. So this could be, and we pre-integrate with OAC. So if you're an OAC user, you can just go provision one of these clusters and just connect to it and then start running your analytics. So very, very simplified. We're really trying to, it's all about simple. We're trying to make this very, very simple to get to your data because it's a big point of struggle right now. We have a shared catalog. So all of the data and metadata does not live within a cluster that you provision. So it's complete separation of compute and storage. The data lives in object storage. The metadata lives in what is called the OCI data catalog. And so what you do is you can provision a cluster. You can start creating SQL tables. You can start querying existing SQL tables. If for some reason you want to provision a new cluster for a different department, they will see all of the same data and metadata. Okay, so you have that sharing. If you want to get rid of a cluster, you can delete it with no consequences. None of the data gets deleted. None of the metadata gets deleted. Another big problem that people have is security. This is all great, like SQL and scalability, that's all awesome. What's going to prevent me from deploying one of these? Well, if I can't govern the data properly, I can't give this out to anybody. Like I'm not going to let OAC connect to this thing and it's just wild, wild west and everything is open. So within Dataflow, you can create SQL roles. You can have granular security policies just like you would with any other database. So the nice thing about this is, I think you can probably hear my helper outside. Right. He agrees. He agrees with all of my points. But the nice thing is that this allows you to start using your object store like it was a database. Sometimes we call this it's a database for big data. Okay, so you can start creating these relational views on top of your object storage. You can start running the SQL queries. And the nice thing is it's all completely ephemeral. It's been, another department wants access, give them another cluster. Tired of this cluster, just shoot it in the head. It doesn't matter. Because all of that stuff, all of the metadata, all of the roles, all of the policies, it's all externalized.
Those are great points around the shared metadata piece and the security piece, because I think that of all the pain points we talked about around Hadoop, you can talk about managing it and you can talk about patching it and all that. Those are
data silo. It's a data silo. At the end of the
biggest problem was sharing. I mean, all these customers that I talk to, you end up with multiple Hadoop clusters. You have people that want to share the data across, but they have to have very, fine-grained security access. And no matter how advanced, your Ranger policies are or whatever you want to call it, it never came close to what you can do with the database, right? And that was a huge pain point for so many customers. And then, of course, the catalog, right? Having that integrated catalog that can sit on top of your object store, right? I mean, right now, one of the biggest problems for me with object storage is you can put a petabyte of data out there. Good luck finding anything, like literally good luck. If you don't know where to look, you're going to be scanning through billions of folders named ABCFF0001, some hexadecimal ID. You're going to have no chance finding anything, right? But you start adding the ability to, lay down some kind of view on top of this where you can start to do workable interactive querying against it. Now you can actually start to discover what's out there and find ways to add value. So I think those are, that metadata piece is absolutely huge.
When you pit the interactive SQL against, I'm going to use a database here, for example, or whatever. You said explore first. So is this meant for dashboards? Would be one. and then two and such. And then my next question would be is, what is the cost? If I keep spinning up these clusters, right? Is it get really crazy cost, or how do we help keep the cost limited? You see, I guess that's
absolutely. So those are great questions. I think we look at it really. It's kind of a process where people will use object store to dump a lot. People will use it like a data swamp. They will just dump a lot of crap into it. Right. Log files, video, anything is fair game because it's really easy, is really cheap. So what we look at it essentially is like a process where step one is I need somebody to go in there and just discover what the heck is in there. And so this is where the OCI catalog can do automatic discovery for you and kind of publish that metadata into the catalog. If that's not good enough, if you need something a little bit more structured, you can connect your favorite BI tool or your favorite SQL query tool and just start querying the data that's in there. Understand the structure. So the process is basically step one: get somebody in there, start understanding the structure, start creating those relational views on top of that. And then step two is really, clean that data up or optimize that data so that you're really just focusing on the key things. Like if you look at highly nested data, generally, business analysts can't deal with that stuff because there's just so much irrelevant stuff in the way. You need to create a view and do extractions. So the point is really, you still have a data engineer here who's going to discover that data, clean it up a little bit. And the last feature that we have in Interactive SQL is an ability to create OLAP cubes. One of the other big problems of querying unstructured data is it's really slow. Right. If you're looking at, like if you do raw query of JSON data, don't expect that to be quick because you got to parse it and it's very, very expensive. Okay, so what you can do in Interactive SQL is you can actually create an OLAP cube. On top of that, it'll pre-summarize the data and accelerate the access to that. And there's plenty of examples that we have that basically, if you start with like a JSON data, CSV data, create a cube on top of that, we accelerate that access more than 100x. Okay, so if you want fast analytics on unstructured data in object storage, you have that ability, you have that OLAP cube there, and you have full fidelity to the underlying data because it's in the same place. You can query it from the same place. Okay, so that's all great stuff. But the idea is that data engineer is going to go in there, discover, clean up, publish fast access to the business. Okay, and that's where you're going to start hooking up your dashboards, and that's where you're going to hook your OAC up to. That clean, so it's not fundamentally different from the process you would do to publish to a warehouse, except that the data is now all in one place. You don't have a lot of copies floating around. A lot simpler, and you can export to the warehouse as well. In terms of cost, one of the this is meant for very large volumes of data. Is meant to run. If you look at Dataflow, you can run this on a 5,000 core cluster, on a 10,000 core cluster. You can get to some really insane scales for people who have a lot of data. You can do that. The cost of this is with the interactive SQL feature. What you're going to pay for is you're going to pay for the hardware that you use. You also pay a service fee of 2 cents per core hour. So there's a small uplift on top of the hardware that you use, but it's actually a very economical service when you're using this interactive SQL feature, and you get access to the security. The security's baked in. It's not like some premium thing. OLAP is there. It's baked in. It's not a premium thing. So it's very economical to run this at very large scales. What we see is, hey, if you have small data, go use a warehouse, right? It's easier. It's faster. It's better. But if you got like tons of log data, tons of JSON files, and a bunch of other low value, high volume, low value data, this is a great solution for that because you can query all of it, you can clean all of it, you can discover all of it, and you can publish it and start running business dashboards on top of it. So great solution for that.
Do you envision, I know this is going to be the first release, so it won't be there, but do you envision it being elastic in nature in the future, right? Let's say at nighttime when no one's running queries, right? we might keep a couple workers active, right, to keep everything in hot, I'll call it. But then in the morning, it could scale up, right, and allow those queries. Do you envision that in the future, or?
So yeah, so way it is today, auto scaling is not in V1, but you can scale via API call anytime you feel like.
Right. So it is elastic
so,
in the sense that you can scale it yourself. That's what I.
So what you could do is, like, if you got a scheduler, you got an enterprise scheduler. Okay, 6 a.m. Just have that thing fire off a call that says, hey, scale it up. It just, people are going to be hitting the office pretty soon. So you can absolutely do that. Auto scaling will come in the future.
Oh, cool.
And I think auto scaling is great, but I think it's not necessarily, as much value as people want to believe it will be, right? I mean, I think at the end of the day, you do your test. You can save all kinds of money by building out a small development environment, doing all your testing, setting up your catalogs, setting up all of your tables, getting it all working end to end, and then scaling it as your user loads come in a very easy way, right? I mean, it's a little too slow, press a button, it's faster, continue doing that. One thing we didn't talk about with Spark is that Spark, theoretically, right? We can always talk about theoretically, but Spark scales like infinitely, right? So as long as you keep, it's a distributed, completely fully distributed technology. As long as you keep throwing hardware at it, you can put more and more data into memory. You're going to get performance gains by doing that. And having this thing be able to scale that way and efficiently and easily, right? Without having to do any of the work yourself as the end customer, that's huge. So I guess we're kind of getting here towards the end where I'd like to kind of wrap up. Obviously, thank you so much, Carter, for joining us. This has been super, super informational and helpful. And I hope that our viewers have also gotten a little bit of benefit from, listening to not only where we've come from, why we've gone here, where we're going, but then also how Oracle is trying to address this, right? So maybe Carter, if you want to maybe have a quick second to wrap up, you wanted to put a little icing on it. How would you spend that?
Yeah. So I mean, we're really excited about this launch. Again, limited availability, end of, I'd say kind of early to mid-July. If you have customers who are interested in kicking the tires on this, absolutely reach out. So we're very excited about this. We think it's going to massively simplify access to unstructured analytics on top of Object Store. Make it a lot, hook up your OAC, hook up your favorite BI tool. Very, very simple. We're very excited about that. It really just makes big data a lot more accessible in the OCI ecosystem. So
Absolutely.
if you got customers who want to try it out, drop us a line.
What type of customer would we be looking for? What are you looking for, the sweet spot? What is the type of customer? There's a lot out there, and people will say this is the silver bullet for everything, right? So
yeah, I think the key thing. One of the questions is, does customer have unstructured data? Do they have it in OCI object storage? I think one of the things that because you got to have the right ingredients to start making this cake, and one of those is, do you have a lot of log data? Is there log data that you wish you could analyze that you're not doing? Do you have it in OCI, or are you willing to put it in OCI? Because the real value prop here is not that we're going to reach across to Amazon and do your analytics there. That really compromises our speed proposition. We need that data to be in OCI, this is best for those very large volumes of data. So
I think the other thing that, real quick, I don't want to derail your thought too much, but the other thing I want to call out here that's super important is that not only just log data, but also our SaaS customers. So right now, traditionally your SaaS customers always been able to access the database. That's not something that happens anymore. We have several different tool sets around how to extract data from your SaaS applications, but where does that data land, right? It lands as flat files in object storage. This is a huge step forward in our capability to service those customers' reporting needs directly from object storage at scale, because you're going to get very large volumes of data coming out of these SaaS applications. Some of it's certainly mostly structured, but they're going to need to have that performance against large scale data sitting in files that they can do that slice and dice analytics that they're used to doing out of databases against, right? So that's something I want to call out as what I feel like is going to be a really big hitting area. And remember, any of you guys that are customers on this as well, reach out to us, right? Reach out to Carter. I'll have his information in the comments. We want to talk to customers that are interested in doing this.
Yeah, you bet. Yeah, I think that the sweet spot is anything that's a large volume of data. Some people, there are customers out there who have extreme volumes of structured data. It's less common than extreme volumes of unstructured data, but they're out there. So this is a good way to build analytical sandboxes, and it can really be any type of data. But the sweet spot is for multi-terabyte. That kind of scale. If you got that kind of scale, or if you're going to get there within the next 3 years, these are the kind of solutions that you should be looking at.
Yeah, we're talking like tens to hundreds terabytes, right? I mean, at some point, because
absolutely.
we can handle single multi-terabytes pretty easily in the database, for example, if that was something that somebody was going to do. And I think the other thing that you touched on a little bit is that's part of the conversation is cost. The cost of an Exadata for 20 terabytes of data, while the performance might be where you need it to be, is going to be very, very different than the cost of something like this against that same 20 terabytes, right? You're going to be coming in a lot more efficient, a lot cheaper. So I think that that cost per performance,
that's the trade-off.
Right.
It's a lot cheaper. It's not going to give you the fastest query results. It scales really well. But if you need that sub-second query, that's where data warehouse is going to come in. So that's the trade-off. Is a lot of people have use cases where, hey, I don't need the result in 5 seconds. I don't need the result in 2 seconds. So that can be a good fit for a solution like this, which scales further and is a lot cheaper.
And as you said, the data doesn't move, right? And that's the key. It just sits in object stores.
That's the biggest. I mean, honestly, you're going to drive yourself crazy having multiple copies of the data running around, and you can never get any of your tools to agree on what the right answer is. So consolidating, using the lake as a system of record is huge for any of these for any of these kind of applications, which are good. Unstructured data cases, especially like IoT, log, sensor. Using the lake as a system of record is huge.
Absolutely. All right. Well, I mean, this was a really great conversation. Thank you, everybody, for joining us for this Cloudology episode around high volume SQL. I hope you guys learned something. And we will see you next time. Thank you on behalf of Carter and Larry, and thank you for me. See you next month.